Okay, for small t, we found that the curvature is about 1 over a squared plus 16 over pi squared a to the fourth. And that's a result that we had right here. And I'm just going to factor out 1 over a, which is equivalent to factoring 1 over a squared out of the expression under the square root. So I get 1 over a times the square root of 1 plus 16 over pi to the fourth a squared. Now, if a is very small, this term could get big. But if a is at least 1, remember pi to the fourth is more than 81. 16 is 1/5 of 80. So this term, as long as a is greater than or equal to 1, is going to be at most 1/5. The square root will then be at most 6/5, which is 1.2. And you can verify that 1.1 squared is 1.21. So that this expression is no bigger than 1.1, meaning that for a greater than or equal to 1, the curvature is about 1 over a, and it's off by less than 10%. Square root of this number is less than 1.1, meaning that this approximation can be off by at most 10% if a is greater than or equal to 1. And if a gets larger, of course, this term gets a lot smaller. And the approximation gets better and better as the radius of the curve increases. So, bigger a is, better this approximation. But as long as a is at least 1, the approximation is pretty good, and our curvature is pretty much equal to the curvature of the circle that we'd have if we didn't have the k component. Now, one thing bothers me about this, as t approaches 0, this should approach an exact result, and it doesn't. This 16 over pi to the fourth a squared appears to me to be the result of some sort of an error. So I'm going to have to go back through my calculations and see what kind of an error I might have made here, because I really would expect that for small t we would get exactly 1 over a, and we wouldn't have to fudge around with approximations. Actually, I'm not going to go back and find my error. I'm going to kind of leave that as an open question. Now, I actually did make that error. I'm not sure where that came in, somewhere in the bookkeeping of our derivatives. This can't be. Okay, we just can't have that's 16 over pi to the fourth a squared when t is very close to 0. Because when t is very close to 0, that t squared k doesn't amount to anything at all. And it's not going to affect our radius of curvature. When t is close to 0, we're pretty much going to be on the circle in the xy plane, and it has a radius of curvature of 1 over a. And it doesn't matter what a is, that's going to be the curvature. So something is wrong. So see if you can find the error. Again, this is an honest mistake that I made. I messed up something, and it's not so much that I don't want to go back and find it, is that I do need to go on and get some more stuff, get some more stuff done for the benefit of everybody, and I just can't take that time right now. So there's a question for you to think about.